Next, we're going to consider what happens when we flip a coin 12 times. The fact that it's fair just means that it's equally likely to be heads and tails. That's irrelevant for us. But we're flipping a coin 12 times, and we want to know how many outcomes are possible. So there's going to be 12 different events that happen, or 12 different things that we can think of. We can think of flipping a coin 12 times or flipping 12 coins. And then each of these is going to have two possibilities, heads or tails. So altogether, just using the straightforward product rule, there's going to be 2 to the 12 possibilities. Okay, so there's 2 to the 12 outcomes. Next, we want to know how many ways can we get exactly 9 heads. The way that I want to think about this is going to be a little bit different than what we did before. So I want to know in how many ways can we get exactly 9 heads. So of course you could have all the heads right up front. You could have 9 heads and then 3 tails. So make sure I can count here. So 3, 3, and I need one more. And then 3 tails. And of course you could rearrange these if you want. You could have, in whatever order you want to put these. So we just want to know how many ways are there to get exactly 9 heads. The way to think about this is basically what you're doing is you have 12 spots. 3, 4, 5, 6. 3, 4, 5, 6, and you're trying to figure out in how many ways can 9 of them be heads. So imagine that you write down an H for heads or a T for tails, like we just did before. And what you want to do is you want to choose 9 of them to be heads. So let's say we want to choose 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so those 9 are the ones that get chosen. And how many ways are there, if you have 9 spots, how many ways are there to choose 9 of them given 12? Well, 12 choose 9. So that's the number of ways to get exactly 9 heads. How many ways are there to get exactly 4 tails? Well, it's the same idea. You have 12 spots, and you want to choose 4 of them. I want to point out one thing that I'm going to come back to. The number of ways that you can get exactly 9 heads is the same as the number of ways that you can get exactly 3 tails, because those are exactly the same outcome. So 12 choose 9 and 12 choose 3 have to be the same. 12 choose 4 is the same as 12 choose 8, because figuring out the number of ways to get exactly 4 tails is the same as figuring out the number of ways to get exactly 8 heads. So these are very similar problems. There's the symmetry here, which we'll talk about in just a second. The same number of heads and tails means that we have exactly 6 heads and tails. So that's 12 choose 6. So there's not much to do there. And at most 2 heads means 2 or fewer. So at most 2 means 2 or fewer. So there's going to be exactly 2 plus exactly 1 plus exactly 0 heads. So that's how we would find that. And then finally, at least 2 heads means 2 or more. So that's going to be 2, 3, 4, 5, all the way up. So you could do it like this. You could do 12 choose 2 plus 12 choose 3, all the way up to 12 choose 12. Or you could count and take all of the possibilities and then subtract the ones that don't give you at least 2 heads. In other words, at most 1 head, which would be exactly 1 and exactly 0. And it turns out that these two will be equal, okay, for reasons that we'll talk about soon in the binomial theorem section. Okay, so there's 2 different ways to count that. One last problem, and I apparently this didn't render correctly, but we're starting at the origin. We want to move, we're only allowed to move only right or up by 1 unit. And then what I want to know is how many paths are there? So how many paths are there to the 0.55? So what we're doing is we're starting with, we have 0, 0. We're thinking of the integers here. So 0, 1, 2, 3, 4, 5. 2, 3, 4, 5. And then we're going to put in all the, these are just all the integers in the first quadrant and on the axes. And what we're allowed to do is we're allowed to take a path from the origin at the bottom left all the way up to the 0.55 on the top right. And we're only allowed to move right 1 unit or up 1 unit at a time. So one path that we could take would be going right, up, right, 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 up, right, up, up. That'd be one path that you could take. Another path that you could take would be, say, a boring path. Go up all the way, up, 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 right, 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 right. Okay, so that's another path. And the question is that if you're only allowed to move right or up, how many different paths are there? How many different paths are there from the origin, okay, down here, all the way up to the point 5, 5 up here? Okay, these are called lattice paths. And the way I want to think about this is I want to think about a path, say the yellow path. I want to think about that path as a sequence of right and then ups, which I'll call R's and U's. So the orange path corresponds to going right and then up twice and then right 3 times and then up, right, up, up. The red path corresponds to going up 5 times and right 5 times. Notice that however many, since we're only allowed to go up and to the right, whatever path we take has to consist of 10 steps. Okay, so there has to be 10 steps. So 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. Okay, so that's one path you could take. And again, the other path, really any path that we could take would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps. They all have to be 10 steps. And importantly, they all have to consist of, you have to go right 5 times, you have to go up 5 times, but the order is up to you. But these are the criteria. So we have to think of this as a sequence of 10 characters, 5 of which are R's, 5 of which are U's. How many ways are there to do that? Well, that's very similar to flipping a coin. Imagine that you flip a coin, and when you get a head, you go up. When you get a tails, you go right. And so how many ways are there to go from the origin to the 0.55? Well, 10 choose 5, because basically what you're doing, another way to think about this is you have 10 spots here. You're choosing 5 of them to be, say, the ups that you're going to do, the up positions. That means that the other 5s by default will be the right positions. Okay, so they'll be the R's. And you have 10 choose 5 ways to distribute those 5 R's and 5 U's. So 10 choose 5 is the number of lattice paths from the origin to the 0.55.